Let's connect the circuit as shown in the schematics. As shown in the schematics, the rightmost green LED anode is connected to pin 15 of 74HC595 IC and all the other pins from 1 to 7 of the 595 IC in the order right to left. The visual indicators we have used here are multicolored LEDs. The two green LEDs indicate that the object is far and it is safe to move your car. The three yellow LEDs indicate that you are closing in towards the object and you can still move your car. The three red LEDs indicate that the object is very close and you should stop moving your car any further. The visual indicators are assisted by sounds from your buzzer. When the green LEDs are on, a high intensity sound can be heard. When the yellow LEDs are on, the intensity of the sound reduces and it further reduces when the red LEDs are on, thus assisting us to park.
Let's have a look at our code. At first, we have to initialize some parameters which are directly related to pins of our input and output devices. Firstly, we are going to initialize our buzzer, which is at pin number 4, an echo pin of our ultrasonic sensor to pin number 9, the trigger pin to the pin number 10 of Arduino, clock pin to the pin number 11, latch pin to the pin number 12, data pin to the pin number 13. Now we are going to use 9 LEDs which are going to display the exact range of the obstacle from our car. So the possible patterns are 9 as we are going to use 9 LEDs. So let's initialize a byte array in where we are going to write all the possible parameters or the possible patterns which we are going to use to initialize the LEDs. Moving further, we are going to initialize a closure is equal to 0, we are going to initialize duration and distance. All these parameters which are initialized are going to be in the form of integer, just the byte array which we are going to use is defined under the byte section. Moving further ahead, under the void setup, we are going to begin our serial program at a baud rate of 9600. First, let's assign our trigger pin as the output pin, echo pin as the input pin, and other pins such as clock, latch, data and buzzer all as output. Now moving further ahead in the void loop section, we are going to make the latch pin low at first. Then we are going to write the trigger pin and make it high. Let's use a delay of 1000 microseconds. Moving further ahead, let's make a trigger pin as low. The duration is equal to pulse in bracket echo pin comma high, and the distance is equal to duration by 2 by 29.1. We are going to divide it in the terms of distance. This is done just because our ultrasound wave is transmitted from one end and it gets reflected and it travels back to our receiver. So we can see that it is a two-way journey. So like to calculate the exact distance, we have to divide it by 2. Let's say at first if the distance is greater than equal to 45, distance is less than equal to 0, serial.println out of range. What is happening is we are going to compare it with a specified value. Let's say this is what and where I am going to initialize my ultrasonic sensor. Beyond this point, anything is out of range for my device. Else, we are going to print the distance in terms of centimeter. Closure is going to map bracket distance, 0, 45, 8, 0, serial.println closure. Let's say if the closure is less than equal to 0, bracket closure is equal to 0. Else, if closure is greater than equal to 3 and closure is less than equal to 4, we are going to change the tone of our buzzer to a certain pitch. So let's say make it tone bracket buzzer, 2 0 0 0 0 0, 2 0 0. Else if the closure is greater than equal to 5 and closure is less than equal to 6, we have to modify the pitch further ahead. So let's make it buzzer, 5000, 200. Else if the closure is greater than equal to 7 and closure is less than equal to 8, we further modified it as buzzer, 1000, 200. Now we are going to shift out the data pin, clock pin, MSB first and provide all the possible patterns under the closure. Now we are going to digital write the latch pin as high. To provide the proper synchronization, we are going to use a delay of 600. Once there is no interference, we are going to make the buzzer as no tone.